Until the okay, we are recording. Welcome to the evening of Python coding. My name is Jacob Barhak. Usually, I host people who show some library, a Python library. Today, I'm going to show you a library a demo of a library myself. It usually happens about once a year that I show a demo myself. Today the library that I'm going to show is called Gina. I'm going to show my screen and I'm going to show you where the demo is. So I'm going to start the presentation. Entire screen. Okay. So the library, the demo of the library can be found in my GitHub account. Its name is Gina Demo. You can find the link above, and you can find it in the meeting page. The demo itself composed of several files. However, to make this work, you will need two more things, and there are instructions how to make it. First, you have to set up the environment and so on and so forth. I'm going to talk about a little bit. You'll have to download the file. The reason I didn't include the file because it's a different license. The demo, I'm giving it to public domain, meaning you can do whatever you want with the code. It's called Creative Commons 0 CC 0. Basically, it makes the code public domain. But this file is a different license, so I could not do it. So you can put it in. You'll have to place some images, and then you'll have to execute the demo. The demo I'm going to show how to execute is basically executing two programs in Python. But first, you have to, of course, set up the environment, and you have to install all the things in the requirements.txt. So let me show you. I'm going to show you my PyCharm. And here's the same README you just seen. So this is how I written it. And this is the requirement.txt file. The first thing you'll need to install, pip install, is Gina. Gina is the library we're going to talk about today. Gina is about deploying AI models mostly. You can deploy probably other things as well, but it's specialized it's fine-tuned toward deploying AI models. And the nice thing about it is that you can run it on your machine, or you can run it on the cloud or in other environments such as Kubernetes. If people who don't know about it, there is such an environment, but there are other environments that you can run the same code. So the idea is to simplify deployment of AI, and you do this because Gina provides you all the correct mechanisms to do this easily. So this is Gina. I also will need Torch. It's PyTorch and Torch Vision. There's the AV library, the Torch, one of the libraries uses it underneath. And there's a library called Dockerray, which actually is provided with Gina. The specific versions I'm using are here. The versions are important because the code will not run on the newer environments of Gina. And the reason they will not run on the newer environments of Gina is because this library is evolving very, very fast. I wrote this demo about a year ago. It's no longer runs on the new versions. You'll have to adapt it to a new version, and some things will take more time to actually do. So let me first explain what I'm going to do. I'm going to show you what the library is a simple video classifier. I'm using a Gina executor for that. I'll explain why I'm using a Gina executor. Now, it's because the idea is that if I wrote this classifier once and later I want to deploy it on cloud environment that will run on many more computers in parallel, then it's very simple with Gina. I just wrote it once and then I just scale it up. And for those who don't know what the video classifier is, so think about it. I'm going to show you a bunch of images. These are images that actually videos and images. The videos I downloaded, those are public domain videos. You have a cute cat, cute dog, dog videos, cat videos. And I also added pictures of myself. This is younger me, this is older me. And I want the system to look at the image and tells me what it sees. Do you see a cat? Do you see a dog? Do you see something else there? Do you see a tree? All of those things is something that a classifier should do. It looks at the image and tells you what it is in text. So I'm going to do this for videos, and I'm going to do this for images. It's all written in the same library, and I'm going to explain how it's going to happen. So first, let's talk about Gina a little bit. Gina has a library that can. It's a library that allows us to execute things. For those who are familiar with other execution mechanisms, then we talked about prefect in the past, we talked about Dask in the past. All of those are mechanisms that allow you to create all sorts of tasks that depend on each other and will be executed perhaps in parallel, perhaps serial. This is, and those environments allow us to do this. Gina is one more of these, but it's tailored towards AI. These days, it's tailored towards large language models more, but I used it for images, as you can see here. So there are two files I'm going to show you. So one of them, I'm going to show it a little bit bigger so you can actually see. PyCharm, it's hard to show it big. So this is the first file. It has the client. The other file, the main file, will have the executor. This is actually has the code of what's going to execute. Let me explain what it means. The client is someone who doesn't know how to do the classification, but asks questions. So think about it like someone is using the web browser to actually ask something from the system to do for them, like classify an image. For that, they have to deliver the image to the executor, and the executor will take that image, do the job, classify it, and return the response to the client. So it's kind of a client-server architecture, if someone is familiar with that term. So we have two programs here. One of them will be only asking questions and passing information and showing us results. The other one will be actually doing the processing, meaning actually classifying the images. Why are there two of those programs? Well, think about it. If you are here in your web browser and you want me, you're sending me an image, and I'm like the web server who is actually processing and classifying the image, then there's also two systems. One of them is the browser that is the client. The other one is the server that does the computation and returns the result. This is how Gina is working. And the nice thing about it is that the client and the server that I wrote here on Windows will work the same on other system, on Linux, and it will work, and you can deploy them on other environments, let's say AWS or Kubernetes or many, many other environments that you can deploy or put it on a Docker file, and it will run for you more or less the same. So with very small variations, and you won't have to make many, many changes to the code. And this is why we're using Gina. And then in the future, if your system is working well for 3 people, then you want to scale it to 1,000 people, then you don't have to make many code changes. You just say, oh no, I want to just scale it. The server will have more processes to run things and stuff like that. That's the basic idea, and this is how we separate this. So let's look at the client code. Client code imports 2 things from the Gina library. One of them is called document array. The other one is called client. Client is just is the mechanism that communicates with the server, with the executor that actually runs the classification. The document array is something specific that Gina has that is tailored towards AI. it has a lot of useful, their documents are, think about it as AI documents. It can be, I don't know, a voice document, meaning a voice recording. It can be a Word document. It can be an image. It can be a video. And the document array, you have many of those. So in our case, we have images and videos all together, and they are all stored in the same document array. Each document is either an image or a video. So here I'm saying, my first line here says, I'm importing all the documents from files from the directory images. And I'm including all of the files, JPEG and MP4, videos and images. So now the client has loaded all the documents. Now it's going to transmit them to, first of all, I define, of course, the client. I haven't defined the client. C is the client here. I define the client, and it says it's working on a specific port on my machine. So it communicates with that port with the server. Then what I do is I'm posting all the documents to the server. You can, I submit it to this endpoint, but you can submit it to a different endpoint as long as the server is listening there. The response of this post will be written in R, and R will be an object with responses with all sorts of text. Basically, those will be the answers for what was in the images. And I just print them out. This is what the client does. It's very simple. It just sets up a connection to the client and reads the documents and posts the documents. Gina knows to accept those documents on the server, and now we're going to talk about how it actually works. So this is the server. The server has three main, I'm narrowing this as three main components. There's a class called prep image, which prepares an image for classification. There's a class called classify image that allows us to classify an image. Both of those are inherited from something called executor, which is something that Gina provides, which actually executes the tasks. And then there's something called flow. Flow looks at the same port. You remember that port the client that was writing? So I just came up with the number. As long as the number is consistent, doesn't matter what it is. It just has to not interfere with other things going on in the system. So the flow, I define it what is the port where the flow of information is going to happen. And what is that flow? The flow would say, oh, I'm going to use prepare image. That's the first part of the flow. And then I'm going to use classify image. So I just defined that the function prepare image will be run, and then the output of prepare image, prep image will be passed to classify image. And then the responses of classify image will be returned to the client after those have been executed. But actually, this doesn't happen. This just sets up the flow. This explains the rules to Gina, saying, you know, we're going to execute those things in this order. What actually executes the flow is what happens in May, in the main part of that Python program. It says with flow.block, meaning you wait until this is being executed and then you return responses. The executor knows how to do this. So far, any questions? Anyone? Okay. No questions. I don't hear anyone barging in, so I will continue. But if I'm running too fast, please. Okay, go ahead.
Oh, hey, hello. I just got here in the meeting, and I'm just wondering, what are you like up to? What's going on? Like,
we're demonstrating a Python program, and we're recording this. So if you're not interested in this demo, then this may not be, but later on we'll be breaking up and not recording, so you can come back later and we'll have a more a freer conversation around Python. But now
Okay, I'm sorry to interrupt.
You're good?
Yes, thank you.
Good. So thank you. So after the but any questions so far about Gina or something? Am I going too fast, too slow? Any comment, please?
Jacob, I have a question.
Go ahead.
So flow.block, what exactly this block function does? Can you a little bit elaborate on that?
So I'll explain as much as I understand. I'm not an expert in Gina, but usually those systems, all of those systems that deal with things that are concurrent, usually have to tell the system to actually wait for this. There's a loop going on in the system usually that says, okay, I'm waiting for things to happen. So flow.block will basically do this for you. It will not end the program. Notice that, like, after this one, the program will not end. It will go into a loop and it will start listening for requests from the client. Different systems have different mechanism or different names to do this, but basically what it does, it goes into waiting state that says, okay, I'm now ready to handle whatever you're asking me. So basically it will not continue from here. And it does this, it takes the flow, it knows that flow is being executed here. And flow is defined by Gina. And I tell it to what port is being listened. If I run the program, this will not stop the program. This line will be, the class will be defined, this will be executed. It's like a function definition. This will set up the structure for Gina of the things that's going to happen one after the other. But then the program continues, and then it says, okay, if you're executing this program from the shell, meaning if name equals main, this is how you in Python define that you're executing it as a topmost program and it's not a library. Then it says, with whatever the context of flow block, meaning from this point on, it's listening. It's not continuing to line 102. It's going into a loop that's like waiting. It's just waiting for us to actually send them some requests. And
probably just a bunch of flow control logic and handshaking.
I did not look inside the code of how block is implemented or flow.block, but basically what it does, it just goes into a waiting state. Many systems have the same mechanism. It's not like different systems like Prefect as well. They all go to a point that says, okay, I'm now ready. You've defined, I know what I'm going to do. I'm now ready. So, and ready means, okay, the program didn't end. When I run the program, you will see it goes into a waiting state. Okay. And then,
okay, thank you.
And then the client, you remember the client I showed you before, then the client can communicate with it. And by the way, there can be multiple clients, each one sending something different to the executor. Got it?
Got it. Thank you.
Got it. Good. So now let's
Jacob,
yeah.
Oh, I got another question in the chat from Barbara. Can Gina pull photos from AI?
So actually, what I showed you is before. I'll show you the clients. It took, this is the images, the photos. It's images I put in the images directory. And it processes them and puts them into a document that then later put in the executor. And now exactly, Barbara is actually leading it to continuation. Now those images will be fed to AI. And how will they be fed? In two stages. The first one is prepare the image. The second one is classify the image. Oh, I didn't say one more thing about the executor before we go into the images. It's like, you see, I added the thing here called replica equals free. It's not very useful here, but it tells you that you can parallelize whatever is going on here with having 3 executors. So you can have like 3 things working on the same, 3 things working in parallel. This is why Gina is useful, because it's going to do the classifications potentially 3 times. But in this situation, it doesn't matter. It's just an example of what is possible. Because now you're living in a world where you can do things in parallel, and it's very simple. You can just say, oh, replicate this. And think about it, those are executors. So if you have a slow things that takes a long time and things that takes that are very fast. So the very fast function might be waiting for many, many very slow functions. So to actually make it efficient, you can say, oh, all the very slow one, replicate them so it will feed the output to the fast one in proper order, so we won't use it. So it will all be processed very, very efficiently. Let's go back and explain what this is an answer to Barbara, but actually it's a continuation. So look at the prep image executor. What it does, it pre-processes the image or the video. It uses torch vision mostly, but some other libraries, but a lot of it comes from the document, the image document that Gina provides. So the structure of the class is such that it responds, it's decorated with something called requests. For those who are not familiar with Python, this is a decorator. This means the function underneath, that's written underneath, is subject to be applied by a different function. The function that he requests is something that Gina provides. And this is useful because now the client sends a request to the preparation of the image, and this class knows how to listen to that request and process it. And we already defined how the port that the request comes from. This is before, if you remember. This is both executor and the client are assigned, are tuned to the same port. So what's going to happen now is this function is going to be executed the minute the document comes through a request in it. And you don't have to write any of the code. It's usually like messy code. You don't have to write it. Gina does this for you. It says, okay, I'm getting the document array as a parameter here. This is my input for that class. And I have inside that class, I have a helper function called prep image for AI. We're going to talk about it first. To process an image, I'm going to use a torch vision model called ResNet. It's a very known image classification model. And for that, it has to have the shape or the image prepared in a specific format. So the shape has to be 200 by 200, has to be normalized, and the color channel has to be in a specific location in the tensor. Basically, the data has to come in a specific way. Those 3 commands shape it, normalizes, and make sure that the color channel is in the correct place. So this is how you prepare the image. So some images will be huge, like, like high definition, like modern cameras, but some images will be small and that whatever it is, you have to reshape them to 200 because this is what ResNet asks you to. So this function, prepare image for AI, we'll see it coming in later on. So if you have documents that we're submitting, and remember, in our case, the documents are either images or videos. So the function, the preparation function, will look at the images or the videos.
Jacob?
Yes, please.
So I have a couple of questions around this. Is it limited to images and videos, first of all, or can you process spreadsheets, Word documents,
Yes,
PDF files, whatever you want?
So whatever you can manage as an AI for AI consumption. But let me be more specific. You can today you apply AI on many things, starting from images, continue with voice recordings, on texts like documents, like text documents, or spreadsheets are basically, today they're submitted as CSV files, but basically those are spreadsheets. Those are basically tables. All of these can be read by Gina to some degree. Now, here's some caveats. The image, when I wrote this program, it was fine-tuned more than images. Apparently today it's more fine-tuned towards other types of AI. I'm not sure, maybe I'm making it wrong, but this version that I wrote about a year ago had all sorts of helper functions, and some of them in the newer versions either disappeared or are hidden somewhere that I cannot find them easily. So I'm showing you something that I written a year ago on an earlier version. Today, Gina advertises itself as some helper for large language models, but you can see that it still has support for things like voice and some other things. And I'm not selling them or anything. I have no connection to them. One day, maybe we'll get someone from there to actually explain what was going on here. But this is the extent of my knowledge, which is barely limited. Okay?
Okay, so next question is, can you change the parameters or questions around what you're looking for to get results out of those, other document types or images? Can you change basically the questions that you want answered?
So, yeah, this has to do with the model. Think about it. You have different AI models that can do different things. There is the AI can do different things. ResNet classifies images, but if you send it a voice recording, then there are models that will transcribe whatever is in the recording. So it's a different type of model. And if you are looking for a large language model, things that processes text and answers questions about them, I don't know, maybe you're familiar with something like what ChatGPT is doing, but ChatGPT is much more complex. But if you have many models like that, ChatGPT is a large language model, or actually it's evolved even beyond that, I believe, but I'm not sure how to define it now. But it started with something called GPT-2. Or even one before that, which is a model that's used, you give it a prompt and it continues whatever you were saying. So basically you give it the start and it continues. So yes, you can change models.
Yeah, I'm thinking more along the lines of very specific questions that you want to look for in a group of multiple document types.
So
such as documents, PDFs, Excel files.
Yeah. So look, the mechanism is here and it's constantly changing. I'm showing you images here in the demo. Go to the Gina documentation and find it out. So just gina.ai, you'll find all sorts of answers there. And I assume you'll find things like that. I know I encountered some of them, but I cannot tell you exactly off the head. It's better that we go later to the website. Can I continue this one for now?
Yeah, I just had those questions.
Yes. It's good that you're asking, and I hope you got the correct answer and it entices you to actually go and actually check it out. The idea is that we show a demo each time of a different library, so sometimes someone finds something helpful and they can later use it. So the documents in Gina can be of many types, but the version that I was using was actually had things like load URI to image tensor. Basically, you give it a URL. URI is either a URL or a file or whatever, and it basically converts it into a tensor for you. And then I prepare that tensor. I prepared the tensor for the document. So the class itself knows how to handle this and has functions to help with this. And I've written a function to prepare it for my specific model. Okay, we're going to talk about the model later. So this I do for an image. For a video, I have to do something a little bit more funny. So there's a function called URI to video tensor. So notice it can handle both images and videos. And it can actually, you can actually ask it to actually give me only the keyframes, because I'm not interested. Let's say the video is like 1,000 frames. I'm not interested in 1,000. Give me the only the scenes, the first one of each scene or something like that. There's something called keyframes that kind of define the video the best way. And when I asked it to give me only those, then it does this for me. And notice, I didn't have to write many lines of code. I just have to use the Gina or actually the document library to actually do it for me. Later on, I'm looking at the tensor and looking at the number of video frames is defined by the first value in the tensor, because a video will have 4 dimensions. The 3 last one are RGB, and the first one will be the frame. So I'm asking it how many frames are there. And for each frame, what I'm doing is I am extracting the image. I'm actually giving it a name, like URI. I'm taking, this is the URI, this URI, and this keyframe. I'm giving it the name, so I'll later be able to trace it where it came from. And then I'm preparing the image just like I did for the regular image for AI. And one more thing Gina provides me is the ability to actually have sub-documents within the documents. They're called chunks. So I have a document, and the document will have sub-documents. So in my case, the document will be the video, and sub-documents will be the images. And then I append chunks. And one more thing I do is to spare memory, I just delete the tensor, because I no longer need the entire video, big video thing. I only need the chunks, only the images I extracted, only the key images. But now they are already prepared and within the document. Now, once I've done that, I've prepared all my documents to AI. Now I'm using the classification. That's the next stage. If you remember, I prepared the images and then they go through classification. So here again, I have the same structure. I have the class. Here I'm initializing the class. The init says here, I'm going to return only 10 classifications per image, meaning I'm asking, give me 10 things. I'm asking the machine, give me 10 things you see in the image, the model. The model can tell you many, but like I'm asking it limited to the 10 best ones. If you change this number to 20, it'll give you more. If you give to 3, it will give you less. And then here's how I load the model. I'm using a Torch Vision model. So Torch Vision is a library associated with PyTorch. If you ever heard about PyTorch, it's an AI library. It generates neural networks and executes them and handles all things around it. Someone have heard about Keras or TensorFlow. Those are very, very similar. There are others that are very similar, but those are the ones. And then the next thing I'm going to do is I'm going to open this ImageNet class index. I'm going to show you what it looks like. It is actually downloaded from a different location. Here's the location it's being downloaded from. Sorry. By the way, this is the Gina library. You can actually go and look for documentation. So you can see, it can say large language models and so forth. But this is not what I was looking for. I was looking for this file. So this JSON file has the classification itself. What's a classification? It says the things you can see in the image. There's a limited number of those, but you can see it can find goldfish, great white sharks, and so on and so forth. This can continue and go on and on and on and on and on and on and on. What I do is I upload this file to the system. This file, by the way, is under MIT license. Everything else I provided here is under CC0, except from the libraries themselves, which is they have their own licenses. So check out licenses if you're doing it commercially. And I load that file, and I just load the JSON file, and I write down the classes. I'll need those later. So this is the initialization. Load the model and load the classes associated with the model. By the way, The torch version that was compatible with the Gina was limited on my machine. So in your versions of torch version, you don't need to do this. If I recall correctly, you can just ask, okay, give me the class, and this file is somehow embedded within the resonant. But double check me on this because I haven't tested it. Then the program itself, the class itself, what it does, the image, the key thing is image doc.embed. This applies the model to the document. Okay? So the process docs gets the image doc as an input, and it applies the model that we initialized, loaded already into the class, and embeds the image document. Then I don't need the tensor anymore, so I release memory. The probabilities are somehow calculated by applying a softmax function. I won't go into details, but believe me, this is a general way of actually getting the probabilities of a certain thing belonging to a specific class. Like the image has like many things that can be in it, and the system will classify and tell you what is the probability of each one of those being in the image. And then I'm asking Torch, which is PyTorch, saying, give me the top K probabilities for the number of classifications that are defined, which is 10. Basically, give me the 10 most probable things that are in the image. It did do it for you. And then I'm going to just turn it into a string. Why? Because I need to return text. So I'm writing a string, and in the string, I actually including the fact that I want to know the confidence of that probability. I won't go into details here. It's simple. It's fairly simple. Standard. If you want more questions, you can ask later. I'll go into more details. Then what I do is I concatenate all those strings, about the 10 strings that I found up. Just give me 10 answers for each image and put them in one big string divided by carriage returns, \n. Finally, the image document, I put everything in the image document in the classifications. That's it. And of course, I include the image URI itself, so I'll know which image the classification came from. So now each document has text that tells you what was the image and what were the classifications on the image. What is the file name of the image? Now, I do something very similar for the documents. I separate images from videos. For images, I just process the document. For videos, for each document in the sub-document in chunks, remember, this is where I store the images for the video. I just ask the process document, and then I extract the summary of all the frames in the video, and then I put them all together in doc.txt. So now the document of the video includes all of the information about all of the video. And that's it. That's the entire program. Let me show you how it works. So I already have an environment that will set it up. I'm going to run the main. You have to run the server, the executor first, because this is actually what does the work. And it does things. It sets everything up. It's not ready. Think about it. It's like a server booting. This is what's going on. It's all happening on my machine, but you can put this on somewhere else. And then it tells me it's working and all the information how to connect to this machine and which port and so on and so forth. And let's run the client. Let's clear this. This is from previous run. What does the client run? It takes all the documents and just sends it to the ResNet. And of course, it does this through Gina. It takes all of those images and videos that I showed you, and it will later get you an answer. This is now, as we speak, is being processed. Maybe it's slower because I'm running multiple things, including this video meeting on the machine, but here, it processed everything and returned an answer for everything. So this is fairly fast because I gave it some videos, some images, and as you can see, it can tell me for each video, for this video, for keyframe F0, here are the classifications. So let's look at that video for a second. So this is a leopard. Not sure which video is this. MP4 video MP4. This is it. Yeah, it's actually a leopard here. So this is a good classification. Let's look at something else funnier. Those AI things are not perfect. And especially this ResNet that I'm using, it's fairly simple. But here, cute cat falling asleep. So it does find out that it's a Persian cat. Here, let's look at the video. Here we go. Cute cat falling asleep. So yes, I'm not saying for a Persian cat, but it's a cat. We can actually run the video and see it. But, yeah. Anyone knows if it's Persian or not? Okay, I'm not an expert in cats, but notice.
Definitely not.
Okay, so, but you see, it says it's either Persian cat lynx or tabby. I have no idea what a tabby is, but oh well. But notice, like on the second frame, the key frame, it thinks it's a harmonica or a spatula or whatever. So, but then there's a Siamese cat somewhere here later on. So there's the videos. Let's look at the images. Here, there's a dog digging. So it doesn't get the dog, but it does find some hound later on and some images. So you can try to figure out, like, do some more AI or do better AI to do this. But think about it. This is a simple example. I just used off-the-shelf things, and it's not that bad, actually. Anyone can explain to me what a tabby is? Anyway.
Okay,
It's
guys.
a type of cat.
It's a cat?
Yeah, it's a breed of cat.
Okay, so you see, it's like it sees cat. So maybe it's wrong on the type of cat, but it's pretty. Here, it's a picture of me. I think it's an earlier picture. Let's see what picture of me is this. Here, picture of me. It's when I was younger. So you can see it says it sees a sweatshirt. It's kind of correct. Let's look at an older picture of me. Here, that's an older picture of me. This is. We should be able to find it later. Here, sample.jpg. So I don't know what the stole is, but it thinks I have. Here, I'll show it to you so you'll be able to see what. I'm going to show them together, side by side, and you'll tell me how good or how bad it is. We don't need this anymore. So with pretty high confidence, it tells me it's a stole. I'm not sure what a stole is, but a bulletproof vest doesn't sound right, but maybe. It's not a poncho. I'm not sure it's a cardigan. I do have wool here. Apron, maybe it thinks it's an apron here. I'm not sure. Chainmail, maybe because it's gray, and a breastplate. It thinks I'm in armor or something, or a sweatshirt. So look, it's not perfect, but for the few little things that I plugged in, it's pretty good. And of course, you can tune those models later on. So I'm going to try to summarize whatever I showed you so far. So I wrote down a small program that does some AI. It uses Gina that stores all of the images and documents and provides me some nice functions that will convert those documents into tensors and stuff like that without me having to deal with it too much. And I can run this now on my machine, but later I can run it on clouds or on other environments without changing the code, or at least not changing the code much, maybe some small nuanced things. And it can run things in parallel later on. So this is its power. It's a mechanism that allows you to parallelize and scale your AI to run on multiple environments. Any questions on that?
Yes, I have a question.
Go ahead.
So, Jacob, literally this Gina helps us to deploy. So I can use my model and on top of that wrap it around Gina and deploy. So
Yeah.
why Gina? What
I
compared to other tools? What
so
I
okay.
will gain?
Okay, so let's compare it to some other tools that I'm familiar with. By the way, there's like many tools right now. It's like it's impossible to figure out all of them. But like what Gina does actually is the deployment mechanism. The fact that you have a client and this executor, the executor sits somewhere on the cloud and you deploy it on the cloud, and the client can be, today it's a small program, tomorrow it's something that's run from a web browser that sends requests. Or this is basically how it works. You have two mechanisms. One of them is the receiving, the one that processing everything, which is deployed. Currently, it's deployed on my machine, but it can be later deployed on the cloud or somewhere else. So Gina is the deployment mechanism of the AI. Now, there are other deployment mechanisms or things that do things that are very similar to Gina. There are many of those tools. The ones I can speak on top of my head is like Prefect, Dask. There's Ray. There's like many of them that can create all sorts of queues of tasks to do that will happen one after the other. Airflow. This is another one. Gina is specialized because they have many functions that help specifically AI models. So the fact that they have those documents in this document array, and by the way, the newer version is structured slightly different. So what you see here is slightly different than what it is now. But the idea is that you have those documents, and those documents are basically the data that you has to be processed by the model. And those documents have all sorts of support. Like if you remember the code I showed you before, here they have all sorts of like those useful functions like where was it?
Chunk.
Here,
Chunk
embed,
function.
just embed,
Right.
apply the model to the image. Just one line. It says, okay, take the model, embed it. So this is, but not resident, but here, there's like, here, set image tensor shape, normalize it. So the documents are useful, can set, can deal with tensors, and they have also functions to help tensors. Tensors is how AI understands our data, because our data has to be processed. And this actually connects to a previous question someone asked me, is can it work with other types of documents? Eventually, all documents you feed to an AI become tensors. It's like whatever text or voice or image has to become some sort of matrix or tensor that like is fed, or n-dimensional array that is fed into the AI. This is how AI works generally today. So those documents have all sorts of useful functions. This is what Gina is more tailored to. And yes, I can do the same things with Prefect, maybe with a few more lines of code here and less lines of code there, or with Dask or some other deployment system. I just showed a demo of Gina these today. Why is it better or worse? We can have a comparison table once, but I rather not go into details because I really am not an expert here on Gina. It's just something else that I used. I can tell you what differences are from like Prefect. Prefect doesn't have things like that, or at least last time I checked. All those libraries evolved very fast. Prefect changed dramatically in the last several times, and last several years. Went through many changes. Also, Dask, I know it's like changing, and now there are libraries on top of it. There are other types of, and by the way, Airflow also, like it's also an orchestration library of many tasks. But Airflow, as far as I know, has a lot of useful. Well, in its family, there's something called PySpark that deals a lot with data, but it does not prepare it for AI, or at least I don't know of something that prepares to AI. If someone knows, then tell me, and we'll book a demo for the evening of Python coding in the future. Any more questions? Questions going once? Question is going twice? Are there no more questions in the chat? Well, quiet.
Just a resource posted if anybody doesn't have the chat open. Kevin posted a resource from Stanford.
Okay.
Good Stanford transfer learning model.
Oh, okay. So, yeah, there are many models. And by the way, you're in the Python meetup. Python is the language for AI models. Any other language will take you much more effort to do this. It's possible sometimes, but if you're talking about the more sophisticated AI models that are available today, Python is your language to go. And think about it. I just showed you something takes about 200 or 100 lines of code, 100 and something lines of code, client and server, that does classification of images and videos. Isn't it cool? Show me a function. Show me a language that can do this the same thing. I'm not familiar with one so compact, so nice, in a way that you can actually understand what's going on. So that's for the developers of Python. They set up a great environment to allow all of these nice things to go in, all of those nice things to go into. So no more questions?
Does the GitHub page also get this video? It's a question from the chat.
I
Or
will
is it
post.
on
I
YouTube?
will post this video in the meetup once it's done. You will find it on the evening of Python coding here on this page, either in the Austin meetup or the DC meetup. You will find comments later on over here. So once the video will be up, probably tomorrow or the day after it will be up, you will find I'll post a comment here. And also you'll find it on the, if you go to the evening of Python coding, you'll find all the videos we've done. These are like all of the things we've done since 2015. So at the beginning, we were not recorded, but once we started recording, you can see that we have videos. So you can go to any one of those videos and you will find them here. And hopefully by tomorrow, you'll have another video here. So just go to the evening of Python coding page. It's on my GitHub account. Just more questions? See how many people have given demos? Many of them are very nice. Actually, all of them are very nice. People actually, it's a great community. I'm happy to be in it. So if there are no more questions, I'm gonna stop the recording. So questions going once, questions going twice, questions going 3 times. No more questions. I'm gonna stop the recording then. The minute I figure out the correct button.